Hi there, I'm Bo. I work here at the Center for Logic and the Philosophy of Science at KU Leuven, and in this brief video I'm just going to give a short overview of what I'm doing here. So I'm in the second year of a 3-year FWO postdoc on the topic of assertion in indirect proof. And to show how this works, let's start with an argument, which is from Zeno. This is the paradox of the stadium. Suppose that motion is possible. Like suppose I can get from where I'm standing here to that white door back there. Okay, if that's the case, then I should be able to get halfway there. To get halfway there, I have to get a quarter of the way, and so on ad infinitum. So really, there seems to be an infinite distance between me and the door. But an infinite distance can't be traversed in a finite amount of time. Therefore, motion is impossible. Whatever you think of this argument, let's look at its structure. Assume A. Assume that motion is possible. Derive an impossibility or a contradiction somehow, and then say, oh, therefore, not A. And this is a very old method of argument. In fact, it's older than logic itself, at least as a formal discipline, as its own discipline, if you take that to begin with Aristotle, 1 century after Zeno. Okay, but then now there are problems. One of them is that you can't prove anything on the basis of a falsehood. You can argue on the basis of a falsehood, but a proof has to have true premises. So what's the role of the false premise in a proof by reductio, in an indirect proof? That's one problem. A second problem is that every line in a proof has to be asserted. It has to be claimed as true. But although that's a general rule that's been a part of thinking about logic for thousands of years, you might think, why would I have a false assertion in the middle of a proof? In a way, it almost looks like it contains something like a lie. Now, a significant development in thinking about reductio comes from the Arabic tradition, specifically in the 9th century with Abu Nasr al-Farabi, and later on with Avicenna. Farabi thought that every reductio proof contains two sort of hidden or concealed syllogisms. One is the law of excluded middle. Either P or not P is true. And the other is that anything that leads to an absurdity is itself absurd. This gets later adapted in significant ways by Avicenna, who treats them as containing an embedded conditional or an embedded hypothetical. Later on in the Latin tradition, John Buridan in the 14th century thinks that the principle of non-contradiction is somehow at play also as a background condition. And then finally, in the 19th century, Frege develops a Begriffsschrift which treats reductio proofs as a form of what's called modus tollens. If P, then Q, not Q, therefore not P. So ultimately, the aim of my project is to draw together all of these historical strands. So thank you for your interest. I'll see you next time.